Electrophilic substitution reaction for the benzene ring is one of the most common questions in paper 2 AQA A level chemistry. You will always find a question related to this reaction and they will always ask you about the mechanism of the reaction. This is the question from the 2024 exam paper, and because this was about nitration this year, probably you're gonna end up with Friedel-Crafts acylation. However, you also may encounter this question in your mock exams. So in this question, they give you a two-step mechanism for the synthesis of an aromatic amine, which is shown here. Two steps. The first step is the nitration step. The second step is the reduction step for the nitro into the amino group. So the first question, they ask you to state the two reagents needed for step 1. Step 1 is the nitration step, and in the nitration, to form the electrophile, we need to use sulfuric acid and nitric acid. So H2SO4 and the nitric acid. So these are the two reagents. And then they ask you to give the equation that allows the formation of the reactive intermediate. So the reactive intermediate is the NO2 plus, which is the electrophile. So here the easiest mechanism or equation you could write is the HNO3 plus H2SO4. That will give you NO2 plus, which is the electrophile, the reactive intermediate, plus water molecule plus HSO4 minus. Then the third question is to ask you to outline the mechanism of the step 1. This reaction has a very common mechanism. You should master this mechanism. So let's start by writing the starting material here. So this is the benzene with the two methyl groups, and then we have the electrophile that is going to attack here. This is the NO2 plus, and then the reaction starts by the curly arrow coming from the ring of the electrons inside the aromatic ring towards the nitrogen, which has a positive charge, and that will give you the first intermediate. And don't forget that you need to write the ring open with a plus charge inside, and then you add the NO2, and don't forget the hydrogen as well, and also don't forget the two methyl groups in the correct position. And then the following step is the when the hydrogen leaves as a proton and the electrons go back inside the ring to reestablish the aromatic system. So the final product will be the nitro substituted compound. Don't forget to put all the substituents in their correct position, and of course the hydrogen plus will leave, or the proton is going to leave as well. And then the next question, they ask you to state the reagents needed for step 2. So in step 2 here, there is a reduction of aromatic nitro to aromatic amino group, and in order to do that, we need to use 10 and HCl. So it's N and HCl. Normally in this reaction, when you use the 10 and the HCl, that will give you not only the reduced product, but also will give you the ammonium salt. So you can then use sodium hydroxide to get the amine. However, if you write the sodium hydroxide, don't just write it next to the 10 and HCl, because this is wrong. You have to say then sodium hydroxide, then add sodium hydroxide, or you can ignore this completely and you will not be penalized. The final question is to state a possible use for the amine formed in step 2. There are several uses for the amines. One of them is to be used as dyes. So you just need to memorize one of the uses of these amines.